Okay, in this video, I'm going to start talking about domain. In the previous video at the end, we did briefly talk about domain and range. Again, domain has to do with the x values, range has to do with the y values. I personally find it easier when I'm looking for domain. Again, domain is really what we're going to be focusing on in this class. I find it easier to find what x can't be, and then I can decide what the domain will be rather than finding what x can be. That's kind of confusing, so let's look at an example. Let's look at f of x equals 1 over x. What value here, what value of x can x not be? 1 divided by x. What's the one number that x can't be here? X cannot equal 0. X cannot equal 0 there. All right, so we have to leave that one out. So the domain for 1 over x, it could be written as from negative infinity to 0, not including 0, unioned with 0 to positive infinity. Okay, so x cannot be 0. We can't divide by 0, and that's going to come up a lot. And the other example I want to show you is the square root of x. If I only want real valued functions, what values of x can x not be? So for this to be real, x has to be greater than or equal to 0. That's the only thing it can be. Otherwise, it's negative, and then we're getting imaginary numbers. And for functions, we want to focus on real values. So the domain for this is going to be 0, including 0, to infinity. That's what we need, all right? These are really the two cases that you can focus on and solve all of the problems for domain. You can find all the domains if you focus on you can't divide by 0 and you don't want to take the square root of a negative number. So just those two cases, we can solve all of the problems. Okay, let's find the domain of this function. F of x equals 1 plus 4x over 2x minus 1. So what case is this? Well, this is we have a fraction here, and we don't want to divide by 0. So you can't divide by 0. Can't divide by 0. Okay? Can't divide by 0. So 2x minus 1 cannot equal 0. Can't do it. What value of x would make it equal? So let's solve. 2x cannot equal 1. X cannot equal 1/2. That's it. That's the only restriction we have on this function, is that x cannot equal 1/2. So I'm going to write the domain equals from negative infinity to 1/2, not including 1/2, unioned with 1/2 to infinity. Okay? X cannot equal infinity. Sometimes you'll see the real numbers minus 1/2. Okay? And I think our web work might even accept that. It might even accept something like r minus 1/2. I think it understands that. All right, let's find the domain of this function. F of x equals square root of 5 plus 2x. This is the other case where we don't want to take the square root of a negative number. So to find the domain, I'm going to say 5 plus 2x has to be greater than or equal to 0. All right? Well, let's solve for that x. 2x is greater than or equal to negative 5. Okay? Divide by 2, x has to be greater than or equal to negative 5 over 2. Okay? So this is the values that x can be. Again, if you want a number line, I could draw a better one than that. If you want a number line, it looks like this. You have negative 5/2. You want to include 5/2, and you want all of the values that are greater than negative 5/2. Well, the domain then must be from including negative 5/2 to infinity. Okay, so that would be the domain for this function. So it's not too bad if you know what you're doing. You just have to kind of be patient with yourself. All right, let's look at this example. F of x equals x minus 3 over x squared plus 9x minus 22. What case do we have here? Well, we have a fraction, and I can't divide by 0, so I need to find x squared plus 9x minus 22 cannot equal 0. So how can I solve this? Well, can we factor this? This is certainly a leading coefficient of one problem, so I'd have to find the factors of negative 22 that add to 9. Seems like 2 and 11, some kind of version of that might work. I'm going to say negative 2, 11 would probably work. So that looks like it's x minus 2, x plus 11 cannot equal 0. When is this going to equal 0? When x equals negative 11 and x equals 2. So x cannot equal those. All right, let's draw it on a number line, and let's draw a better number line. Let's see, where does that happen? I'm interested in negative 11. I'm interested in 2. I don't want those values, that's the point. And I want all other values included. All other values included. So it looks like the domain is going to be from negative infinity to negative 11, not including negative 11, union with negative 11 to 2, not including either, union with 2 to infinity. All right, 3 regions, 1, 2, 3. Okay, and we're just trying to skip negative 11 and 2. Now, a more compact way would be r minus braces negative 11 comma 2. I'm not sure if WebWork accepts that. I would have to double check, but that is a more compact way of answering that question. All right, for my last example here, I want to say, what is the domain of f of x equals negative 2x squared plus 5? So, is there a fraction here? No, there's no fraction. Is there a square root? No, there's no square root. So there's no restriction. There's no restriction to this. Okay, and that's what we saw in the previous video with that parabola. There was no restriction. There's no restriction whatsoever. So it's from negative infinity to infinity. That's the domain. Okay. All right. I think that's going to be it for this video. I hope that helps in finding the domain. This is how I personally find the domain of functions. I find that I can solve any domain question just thinking about those 2 sample cases of I can't have a fraction and I can't have a square root. And everything else I'm able to kind of suss out what it needs to be. All right. Please reach out if you have any questions, but I think that will do it for domain as of now. All right. See you next time.